Let me, yeah.
I just want to make sure we haven't had anything like due up until this point.
All right. Okay, so today's Wednesday. I don't know if people say happy Wednesday or not, but happy Wednesday. I was going to say, the first homework is, that's going to be actually due. It's going to be available today. Sorry. The first homework is due. It's going to be available today. I can't get my thoughts together. It's going to be available today at 2, and it will be due Tuesday of next week. Excuse me. It'll be due Tuesday of next week by 11:55. That's also posted on the calendar for Blackboard. Just want to give you guys a heads up. It will be on Lumen Learning. I do expect to put a quiz up there. Again, the quizzes will be take home as well. I'll keep everyone posted. So just letting you know. Okay. So let me get started. I think one person had a question. Does anyone else have a question, or can everyone hear me?
Yes.
All right, good. Okay. Just turn that off. Okay, I was just concerned because I think someone said they couldn't, so I just wanted to make sure. Okay, thank you. All right, let me start sharing the slides. I did email everyone the lecture notes. So here we go. All right. Can everyone see it? Oh, there they go. Good. Okay. Okay. Okay, so now what we have is we did addition and subtraction, right? Now what we're going to do is multiplication of monomials, okay? So now what we're going to do is multiplication of monomials. Okay, now to actually multiply monomials together, and then just like with addition and subtraction, we will take it an extra step further to polynomials. For monomials, I think I might have mentioned this last time as well, we multiply the coefficients together and we use the exponent rules for the variable. So for the calculated product, right, the coefficients are A and B. We multiply the coefficients together to get A times B. Then we do x raised to the m plus n. We do x raised to the m plus n. Okay? That's what's going to happen there. So that's what we get. Now, okay, so now that's what happens, okay? So for instance, let's do some examples. If we were multiplying these two monomials together, right? We have 4x times 7x cubed. And so what do we get here? Well, we get 4 times 7, which is 28. And we have x raised to the 1 plus 3. So for x, right? Remember, the exponent, if it's not written, it's understood to be 1. So we have x raised to the 1 plus 3. 1 plus 3. So we get 28 times x to the 4. That's what we end up with. Okay? So that's what we get here. Now from here, for this example, same idea, right? We have minus 5 x to the 7 times 20 x to the 6. Multiplying them, we get negative 5 times 20 times x raised to the 7 plus 6 times x raised to the 7 plus 6. So then we get negative 100, and we do that times x raised to the 13. Okay? That's what we get here. And again, we're just adding the exponents for the variable. Are there any questions on this so far? Remember, I can't see the chat, so if you have a question, please use the hand raise feature. Okay. Now that's for monomials, okay? And again, we're going to generalize from monomials to polynomials. Now there's different ways of multiplying. You know, remember how we went through different ways of adding and subtracting? Well, there are different ways of multiplying as well. For instance, we have distribution. With distribution, what we're going to do is this. You multiply each term of the first polynomial with each term from the second one. And then you just add up the results. So again, we multiply each term from the first polynomial. You're going to multiply with each term from the second. And then you just add, the results together. Okay? All right. So this is one way of multiplying. I will show you another way as well. Let's just work on this though. And again, it's really good to write your answer in standard form if you can. It's really good to do that. So here's our first example. We have 4x times 7x cubed plus 1, let's say, right? So to use distribution, what we're going to do is this. We're going to have 4x times 7x cubed, right? Plus 4x times 1. And so from here, we end up with 4 times 7 is 28. 28 times x to the 4 plus 4 times x. Excuse me. That's what we get here. Okay, so again, maybe this is kind of hard to see from this example. From each term from the first polynomial, you multiply with each term from the second, and you add the results. Now for this one here, it's the same idea, even though it's going to look a little different. Well, it's going to be a lot more terms. We have x to the 4 times 2x squared plus x to the 4 times x to the 5th, right? 3 times 2x squared, 3 times x to the 5th. And again, we're adding up all the terms together. So again, we're multiplying each term from the first polynomial with each term from the second polynomial. Okay? And again, we just add the results. Someone have a question?
Yeah, so for the second one, when you have two polynomials, the x to the 4th plus 3rd and the 2x squared plus x to the 5th,
Yeah.
could you put those in a box and do it that way?
That's actually the other method I was going to get to. So.
Oh, okay.
That's awesome. Okay. Okay. Yeah, I'll actually get to that though. That's actually, I think, what they call it, the box or the grid method it's called, but we'll get to that also. Okay. Awesome question. So for this one, we have, when we do the product, right, we have 2 times x to the 6. Again, you're just adding the exponents. The coefficient here is just 1, okay? And also, again, I did email everyone the notes, so, just letting you know. For this product, we have x to the 4 times x to the 5th, which is x to the 9, okay? Here, we have 3 times 2x squared, which is 6x squared, as you can see, okay? And here we have 3x to the 5th. And from this line to this line, we want to write it in standard form. So basically what I did was the x to the 9, that's the biggest exponent of x. So we put x to the 9 in front. 6x squared has to go in the end because 2 is the smallest exponent. Remember, you want the exponents to decrease as you go from left to right. Okay. Okay. Now, sorry, are there any other questions on this? Okay. So now, what we actually just did was, you might have seen this before, it's called FOIL. FOIL, it stands for the first terms, So if you're multiplying two binomials, binomial is a polynomial with two terms. You have the first term, right? The first terms you have here, that's what F stands for. The outer terms, that's what A and D are. Inner terms, that's B times C. Last terms is B times D. That's what those are. A times C is the first, outer is AD, BC is the inner, BD is the last. Okay. And that's actually what we did here. I mean, it's distribution, but you can remember it as for two binomials as FOIL. And this is actually what I'm doing here. You could do 3x times 2. You have 3x times minus x. That's where this comes from. 4 times 2. And 4 times minus x. And then we're just adding up the results. Although because of the negatives, we end up subtracting these. When you do that, this is what you're going to get. Excuse me. And we end up with this. Okay. And so from here, right, what we want to do is when we combine results, we have 6x and minus 4x, right? Those are like terms, so we combine them to get 2x. So this is our answer. Again, to go from here to here, I just rewrote it so that the minus 3x squared is in front, 6x and minus 4x, right? That's 2x, which is in the middle here, okay? And the 8 is at the end. And the 6x and 4x we just combine, they cancel. I can't see the chat, so does someone have a question or?
Someone in the chat just said FOIL stands for first, outer, inner, last.
And last.
You want to stop.
Yep. Mm-hmm. Yeah, exactly. Very good. Okay. All right. All right, thank you. Okay, so that's FOIL. Let me do another, and these are just some other examples I thought it'd be good so to look at. Again, it's always the first. Wait, is that the? I thought it was the same example. So we have the first terms right here, the outer terms here, the inner terms here, as you can see, and we have the last terms, as you can see. So from here, right, this is where we get these terms from. Again, I'm using FOIL here. The first terms, that's this product, which gives us 6x to the 7. The outer terms are 2x to the 5th times x, which are these here, as you can see. The inner terms is negative 5x times 3x squared, which is this. And then we have the last terms, minus 5x times x, that's here. That's what it boils down to. We also have this product and this product. Okay. So again, I'm just doing these products using FOIL, right? If you actually carry out the products here, when you do that, you'll have x squared plus 3x minus 3x. I know here I wrote x times 3, but it's the same thing as 3x. Minus 3 times 3. And you can see there's some cancellation. We just get x squared minus 9. Which is x squared minus 3 squared. Okay, so that's what we get here. Get the recording going. Okay, let me just pause.